f of x is continuous at the number a if and only if the following conditions are satisfied. Una dyan, f of a should exist. Kalawa, dapat yung limit of f of x as x approaches a meron din, nag-i-exist din. And finally, kung naman yung f of a, dapat equal yun dun sa limit of f of x as x approaches a. Okay, na-highlight ko itong a na ito para mas makita natin na magiging continuous lang ang isang function at a certain number kung halimbawa, yung number na yon i-plug in mo sa lahat ng x mo dun sa function at may lumabas na finite value. Yun yung ibig sabihin ng a. Yung b naman, kung halimbawang yung number na tinutukoy natin mag-i-exist kung hahanapin natin yung limit ng function habang ina-approach ng x natin yung kaparehas na number. Higit sa lahat, bukod sa mag-i-exist itong dalawa, dapat parehas sila ng makukuha nating value. So para mas ma-visualize natin yan, ayan yung ipakita ko sa inyo ang ilang halimbawa. So this is the graph of x squared plus 2. Ito ay isang parabola. Subukan nating alamin kung siya ba ay continuous at, let's say, 0 at x equals 0. Continuous at x equals 0. So, yan yung gusto nating masagot. Una nating tingnan, dapat merong f of a. Meaning, if I plug in 0, in this example's case, ito yung magiging a natin, ano? If I plug in 0 dun sa ating function, lahat ng x ng ating function, dapat may makuha tayong finite na value. So, f of 0 is 0 squared plus 2. 0 squared is just 0 added by 2. F of a is equal to 2. Ibig sabihin, if we plug in 0 dun sa lahat ng independent variables ng function, lalabas itong 2 bilang output value. Makita natin yan dito kasi if x is 0, nandito yun sa origin, ano yung magiging y coordinate? Ayun, 1, 2. So may ordered pair na lalabas, di ba? If x is 0, y is 2. So nag-i-exist si f of a. Defined yung function na ito at x equals 0. How about its limit? Dapat daw mag-i-exist ang limit ng function natin as x approaches that value. Ani a natin? Again, 0. Hindi pala x equals 0, x approaches 0. Yan. So kung gagamitin natin yung graph niya para makita yung one-sided limits, alam natin na yung limit, overall limit ay mag-i-exist lang kung parehas ang iyong one-sided limits. Yung limit from the left and limit from the right. Limit of f of x as x approaches the right of 0. Alright? Left of 0, from the left of 0, and then from the right of 0. Dapat equal yan. Check natin. So magsimula tayo sa kaliwa. I-approach natin yung x equals 0 from the left. So mula dun sa taas, may arrowhead. So this will go on forever. Pero mag-start na tayo dito sa nakikita nating part ng graph. Papuntang x equals 0 at habang lumalapit tayo dito sa x equals 0 sa left side niya, no? Yung y value natin pansinin, nagiging 2 rin. So, pwede kong ilagay na yung limit of this function as we approach 0 from the left side is 2. How about from the right side? May arrowhead ulit, so this will go on forever. Start na lang tayo sa part na nakikita natin. Papunta sa x equals 0 and same thing. Makuha natin yung positive 2 bilang output value. So, kung parehas ang ating one-sided limits, limit from the left and from the right, ibig sabihin, merong nag-i-exist na limit. Anong limit yon? Yung parehas na value na nakuha mo. So, the limit of, yung overall limit, the limit of f of x as x approaches 0 is positive 2. Can we now say na continuous ang function na ito, itong x squared plus 2, at x equals 0? Yun yung huli nating tinitingnan, hindi ba? Bukod sa nag-i-exist yung f of a, ito yung f of a, at yung limit, dapat equal sila. Equal ba yung f of 2 dun sa limit of f of 0 rather, hindi f of 2, because a is 0. F of 0 doon sa limit of the function as we approach x, as we approach 0. The answer is yes, no? So yung kanina f of a nakuha natin 2. Then yung limit, overall limit natin nakuha rin natin 2. Which means x squared plus 2 is continuous at x equals 0. In fact, makita mo lang yung graph, malalaman mo ng oo ang sagot. Kasi, pag ginraph mo siya, yung lapis mo, hindi mo na kailangang iangat. Walang mapuputol na bahagi. Walang pag-angat ng panulat na mangyayari. So, that's how you can say if a function is continuous or not. Mangyayari lang yun kung nami-meet lahat ng conditions. Balikan natin to, no? Kailangan lahat ito ay ma-meet para matawag natin na yung isang function ay continuous at a certain number a. Paano kung isa o higit pa ang hindi nag-satisfy o hindi natin nakuha? Then we can say that the function is discontinuous at a. Discontinuous at a if one or more ng alin, nitong property na tinatawag natin. One or more conditions na lang, sabihin natin. One or more conditions, kita kasya, fail to hold at a. Hold at a. At a. So that's the only time na yung function natin ay hindi magiging continuous. Halimbawa, ang nag-i-exist yung limit, pero walang f of a, hindi na siya continuous. Baligtad naman. Halimbawa, may f of a pero walang limit na nag-i-exist, imposible nang mag-exist yung c. So again, discontinuous yung function na yon at a certain number a. Ano yung iba't ibang uri natin ng discontinuity? Unahin natin i-consider itong graph ni x squared minus 9 over x minus 3. Apparently, sang-ayon sa kanyang graph, no, makita natin na may bilog, mayroong butas, mayroong hole. So, pag ginraph mo yan, aangating lapis mo sa part na to, tsaka mo lang ulit itutuloy itong part na to. So, by looking at this, masasabi kong ito ay discontinuous at this certain number. Anong number yan? This is 3. At x equals 3, this function, x squared minus 9 over x minus 3 is discontinuous. Hindi defined itong function na to at x equals 3. So if you try and plug in 3 here, this is going to be 9 minus 9 over 3 minus 3. So, makita natin 0 over 0. Indeterminate, walang sense yung makuha natin. Because again, undefined yung function na yon at x equals 3. So, anong uri na lang siya ng discontinuity? Alam na natin na siya ay discontinuous at x equals 3. Anong uri ng discontinuity? Discontinuity ang taglay niya. Tingnan natin ulit muna yung conditions. So, para masabi natin na continuous ang isang function, una, dapat merong f of a. F of a exists. Check nga natin. A at this example's case, in this example's case is 3. No, gusto nating malaman kung continuous siya dun sa x equals 3. So, A, in this example's case is 3. Kanina plug in ko na yung 3 dito sa function. No? That's how you solve for f of a. At nakuha natin indeterminate form. Or if you like to simplify this, meron tayong makukuhang mas simpleng itsura. So, this is going to be a difference of 2 squares. So, merong x plus 3x minus 3 dyan. Tama, x plus 3x minus 3. Maka-cancel na yung x minus 3. Matitira tong x plus 3. So, pag plinag-in mo na ngayon yung 3 doon sa x plus 3, makakakuha tayo ng 9. Pero hindi yun f of a. Kasi sinimplify ko na eh. F of a, kung diretsong plinag-in ko siya doon sa itsura, original na itsura ng function, yun yung makukuha natin. But in this example's case, nung plinag-in natin kanina, walang nag-exist na f of a. So, x tayo sa part na to. How about the limit? So, the limit of f of x as x approaches a must exist. Prove natin. Kapag ginamit mo yung algebraic method niyan, ganun nga yung gagawin dito. If you found an indeterminate form, you simplify and then you plug in. So, makuha natin sa huli dyan is x plus 3. Plug in natin yung a, which is in this example's case, a is 3 again. So, 3 plus 3, dyan lalabas yung 6. Alright, so may limit tayo. Check nga natin kung tama. So, para mag-exist yung overall limit, dapat equal yung limit sa left. Limit as x approaches the left of a and the right of a. Right side of a. Dapat parehas yan. Tama? Yan. Left and right must be equal para magkaroon ng overall limit. Patunayan natin kung 6 talaga yung lalabas. No? Mula sa graph, approach natin yung a, which is x equals 3. From the left, habang lumalapit tayo sa 3, ano nangyari sa y natin? 1, 2, 3, 4, 5. Well, hindi nga lang to accurate, no? Pero dapat talaga ang lalabas dyan ay 6. So, dagdagan ko na lang to ng isa. 1, 2, 3, 4, 5, 6. Yun. Nagawang pa ng paraan. Yan. As we approach x equals 3 from the left side, yung y value natin magiging 6. Kasi itong point na yan, ang coordinate niyan ay 3, 6. Ganun din ba mangyayari sa left side tayo manggagaling? The answer is again, yes. Galing ka man sa left, galing ka man sa right, makukuha mo yung limit na positive 6. So, nag-i-exist yung limit. Ang problema lang natin, yung huling part. Sabi sa huling condition, dapat yung f of a at yung limit ay equal as we approach a. Alright? F of a natin ay non-existing. Determinate ang nakuha natin. And then, meron man tayong limit, imposible na mag-equal sila. Not equal. Imposible na mag-equal sila. Kahit may limit tayo pero walang f of a. Anong tawag natin sa ganung uri ng discontinuity? Yung meron kang limit na nag-exist pero wala namang f of a. Ang tawag natin sa ganung uri ng discontinuity ay removable discontinuity. Removable discontinuity. Kailan nangyayari itong removable na discontinuity? Again, kung may nag-i-exist na limit pero walang f of a. Bakit siya removable? Pansinin na kung dadagdagan ko yung definition ng function na to, maaalis naman to eh. Yung whole na yan, malalagyan natin ng laman yan. Paano ko gagawin yon? Paano ko dadagdagan yung kanyang definition? Simple lang. Sabihin natin that x cannot be equal to 3. Yan. Pag dinagdag mo yan dun sa function mo, mawawala itong butas. Mawari-remove yung discontinuity. So, kaya siya tinawag na removable discontinuity kasi pwedeng maalis yung putol na yan, yung bilog na yan, yung butas na yan, if you redefine your function. Kung i-state lang natin that x, yung independent variable mo, cannot be equal to 3. So, that's the first type of discontinuity. Pangalawa nating tingnan yung tinatawag nating essential discontinuity. Yung essential discontinuity, dalawang bagay din, no? Pwedeng maging jump or pwedeng maging infinite discontinuity. In this example's case, sasabihin ko na agad sa inyo, this is an example of a jump discontinuity. Jump discontinuity. Bakit jump? Pansin niyo yung graph. Mula sa left, pakanan, may putol, tumalon, tsaka nagpatuloy. Kapag may gap, bukod sa may hole, may gap talaga siya, naputol, tumalon, tsaka ulit nagpatuloy, yun ay jump discontinuity. So this function has a jump discontinuity at anong value to ng x? This is x equals positive 2. So f of x has a jump discontinuity at x equals 2. Tingnan natin yung conditions. So una natin kinicheck lagi yung f of a. Tama? Nag-i-exist ba si f of a para masabi natin na continuous ang function? First condition yan. So sa example na to, gusto nating ma-evaluate yon at x equals 2. Yun yung a natin. So try natin. Since we don't know the algebraic form, kung anong expression natin representing this function, hindi natin magagawa itong i-plug in, Pero pwede natin yung patunayan sa pamamagitan ng graph. Pansinin that if you plug in 2 dun sa function mo, ibig sabihin if you evaluate this function at x equals 2, makita natin na may bilog nga dyan, pero meron namang point dito sa taas. So hindi siya undefined at x equals 2. Defined siya, hindi nga lang dito sa hole, kundi dito. X equals 1 to y equals rather 1 2 3 4. So y equals 4. Define si f of x at x equals 2 kasi may lalabas na point dito 2 4. 2, 4. So may f of a tayo. F of a is 4. Huwag ko na gamitin tong y. Baka malito tayo. F of a. F of 2. Lagay ko to be exact, to be precise, since a is equal to 2. F of 2 is equal to 4. Meaning if we plug in 2 dun sa ating function, ang lalabas na output value is 4. Positive 4. How about the limit? The limit of f of x as we approach positive 2. So para mangyari yan, titingnan natin yung one-sided limit. Tama? Limit from the left dapat equal sa limit from the right. Tsaka lang natin masasabi na merong limit yung overall limit yung ating function. So mula sa left side, dito yun, may arrowhead. This will go on forever. Pero mag-start na tayo sa bahagi ng graph na kita natin. Pakanan. Galing sa kaliwa, pakanan. Lapit tayo sa x equals 2. Ano nangyari sa y value? Naging 3. So, yung limit natin sa left side ni 2 ay 3. How about sa left? May arrowhead, so this will go on forever. Start na lang tayo dito. Papunta sa x equals 2. Anong nangyari sa y value? 1, 2, 3, 4. Notice na yung limits natin, one-sided limit natin ay hindi parehas. Iba yung nakuwang limit sa 3, sa nakuwang limit sa... Iba yung nakuwang limit sa left, sa nakuwang limit sa right. Which means, the overall limit does not exist. Limit of f of x as x approaches 2 does not exist. Ngayon nilalagay natin d, n, e. Ibig sabihin din yan, automatically, itong c natin, yung huling condition na tinitingnan natin, which is f of a must be equal to the limit, hindi na rin pwedeng maging totoo to. Kasi nga, wala na tayong nakuhang limit. Kapag isa lang dito ang hindi mo nakuha, imposible nang maging continuous ang function. Alright? So, that's the jump discontinuity. Again, si jump discontinuity ay tinatawag din nating under ito ng essential discontinuity. Essential. Essential siya kung may f of a pero nag-i-exist si f of a Pero si limit of f of x as we approach a, hindi. So yun yung essential. Kanina, yung removable discontinuity, baligtad. Walang f of a, pero may limit. Limit of f of x as x approaches a. May limit tayo. Tama? Removable discontinuity kung walang f of a pero may limit. Essential discontinuity naman kung may f of a pero walang limit. Pero under essential discontinuity, dalawa yan. Una itong jump discontinuity. Ikalawa ay itong titingnan nating susunod. Jump discontinuity, again, may putol lang. Tumalon yung graph natin. And the second type of essential discontinuity is this one. Ang tawag sa ganito ay infinite discontinuity. Discontinuity. Huwag na natin buuhin. Infinite discontinuity yan. This is again a type of essential discontinuity. Pero bakit siya naging infinite discontinuity? Simple lang. Pansinin na yung magiging one-sided limit mo dito ay parehas mag-a-approach ng infinity. So, let's evaluate the limit at x equals -3. May makukuha ba tayong f of a sa ganyan? Will the function be defined at x equals 3? Yun yung first condition, di ba? Nag-i-exist ba si f of a? This exact if a is equal to 3, -3 rather, the obvious answer is no. Hindi siya pwedeng mag-exist. Bakit? This is a vertical asymptote. Asymptote yan meaning, yung graph natin, lalapit lang ng lalapit yan, pero never nilang itatouch yan. Which means, hindi yan naabot ng ating function. Subukan nilang itouch yan, ano mangyayari? Magiging undefined siya. So, hindi niya pwedeng itouch yung x equals -3 because this function, g of x, is undefined at x equals -3. Ibig sabihin, wala tayong f of a. How about the limits? Limit of f of a as x approaches. Unahin natin sa left side of -3. And then, dapat equal yun sa isa pang one-sided limit natin mula naman sa kanan. As x approaches the right side of -3. Tingnan natin. Meron ba siyang limit? May makukuha ba tayong limit dito? Sa left, this will go on forever. Pababa ng pababa. Which means, may arrowhead. So, this will go on forever. Negative infinity tayo sa left side. Sa right side naman, as we approach x equals -3, pataas tayo ng pataas. Dahil may arrowhead, we will go on forever. Lahat ng positive values ay nasa taas. So, palaki ng palaki yung y value dyan, which means positive infinity. May one-sided limits naman, no? Kagaya kanina sa jump. Kaya lang, unequal. And in this example's case, kaya siya infinite discontinuity kasi yung one-sided limits natin ay parehas infinity. Either negative infinity or positive infinity. So, that's the infinite discontinuity. Of course, pag chinek mo dito yung tatlong condition, yung third condition niyan, malabo na mag-equal yung f of a at saka yung limit. Limit of f of x as x approaches a. So that's the infinite discontinuity. To wrap this up, a function is again will be continuous at a number a kung nami-meet niya tong tatlo. Dapat may f of a, dapat may limit as x approaches a. Higit sa lahat, parehas yung nakuha mo dun sa f of a at saka yung overall limit. Kung isa dito hindi na-meet, discontinuous yung function na yon at that number, yung a, discontinuous siya at a, no? Na alam natin, may iba't iba ring uri. Uning uri ng discontinuity, kung wala tayong f of a pero may overall limit. That's the removable discontinuity. Removable discontinuity because again, kung i-redefine mo yung function, mawawala yung hole. Mawawala yung gap kung saan siya discontinuous. Kalawang uri yung essential discontinuity na meron pang dalawang categories. Essential discontinuity kung may f of a pero walang limit. Alright, so una dyan itong jump discontinuity na makikita natin yung graph, tumalon lang. From the left side, naputol, nagpatuloy ulit pa kanan. Pero tumalon, merong gap sa pagitan niya. So may f of a yan pero walang overall limit. May one-sided limits naman kasi hindi parehas, so walang overall limit. So that's the jump discontinuity under essential discontinuity. The other type of essential discontinuity is the infinite discontinuity kung saan bukod sa wala ka ng f of a, ilan natin, wala kang f of a, wala kang f of a, yung one-sided limit mo pa ay infinite. So, walang overall limit. Limit x approaches a. Again, it does not exist. So, this is the other type of essential discontinuity. Walang f of a, wala pang overall limit. And, yung kanyang one-sided limit ay parehas infinite. So, that will be all in this video. Let me know kung may bahagi nito ang hindi mo ganong naunawaan. Thank you so much for watching.